If you are given a true or false question in the exam to decide whether it is possible to have insignificant t values but significant f values, is that going to be true or false? Well, the answer is that that can be true. Why? Because it is definitely possible to have insignificant t values but significant f values. And in this short video, I will quickly explain why that is true. So we already know that a classic symptom of multicollinearity is that you're going to have insignificant and low t values. So the first part of the statement is true, right? But you may be asked to give the reason why the second half of the statement is also true. So for that, you simply need to look at the formula for t, where you can see that as part of the formula, the standard error is there in the denominator, and I've already explained in another video why the t values become lower, or overall the term becomes smaller when you have a larger denominator, right? So when you have larger standard errors, the t value becomes smaller, and that is why we have low and insignificant t values. So that explains the first part of the statement. But when you look at the formula for computing the f statistic, you will see that there is no component including the standard errors. So because standard errors are not part of the formula for computing the f statistic, so that is the reason the second half of the statement is also true. So even in the presence of multicollinearity, the f statistics are still valid and they are reliable and significant, because the f statistic does not get affected in the presence of large standard errors. It's only the t statistic which gets affected, because the standard errors are part of the formula for computing the t statistic and not the f statistic.